Hey everybody, Professor Jensen here. In our video this week, we are going to talk about life cycles. Now you probably, if you're like students in the past, you probably roll your eyes a little bit when you think, well, life cycles, that's kind of silly, or maybe you think, I don't know what a life cycle is. Well, I want to start this video before I dive into the contents of what a life cycle is with just a little bit of a heads up. At the end of every semester, I have my students fill out a little evaluation form on the things that worked well for them, places where they struggled, what they would do differently if they were to start the course over again, those types of questions. And without fail, nearly every single student says, I wish I would have taken more time to really understand what the activity life and fragment life cycles were all about, and what happened when, and what goes where, because they would end up spending a lot of time trying to pick those things up later after we'd moved on from that topic. So while I'm going to do some explanation of those topics for you now in this video, definitely make sure you're putting enough effort to really understand what's going on with all of the steps of the Android life cycles. Really, because these life cycles are kind of one of the first things you're going to encounter that'll make Android programming different than anything else you've done. Now, this is primarily because Android development is an event-driven paradigm. Now, most of what you've encountered in your education so far, and even sometimes out in industry when I talk to students, is not an event-driven paradigm, but rather, more of a more procedural approach, where you have, like, for example, your Java main class that fires everything off and then it just goes. In an event-driven paradigm, the idea is that the user is driving everything that's happening, and then we're just simply reacting to events that take place as something happens. For example, a user clicks on something, we will react to the event. There's a scroll, a touch, a device rotation, any of those types of things. Those are all events that then the code can react to those. Now, the Android life cycle specifically, if we pull up a little thing about the life cycle, one of the most important things about handling these life cycles, they are going to save you a ton of headache later on. For example, and I'll show you some demos here in a minute, maybe the user gets a phone call while in the middle of your application. Well, you need to handle the activity properly, or the fragment properly, at the various stages of the life cycle to save perhaps their information, so that when they come back, it's as if to the user they never left. However, from you, that's going to take a little bit of forethought and practice to really understand what to do and when. I have a little diagram here, courtesy of Google, of the actual life cycle themselves. Now, up here at the top is where the activity is launched. Now, this means when the user first presses on your application, or in the strange case that you may have more than one activity in your application if you're launching a second one, and then obviously the life cycles start over. But starting at the very beginning, as you can see if we follow through this diagram, the first thing that's going to happen is we are going to receive an onCreate callback. Now, when the onCreate method is called, that means the basic structure of the activity is in place. So anything that we need to create, for example, the UI. So when we want to inflate a view or attach other visual things, the onCreate is the best place to put that. Once the activity has been created, then the activity will be started. Once it is started, it will be resumed, and then once we've gone through the resume method, then we'll be back to an actively running state. Now, we will remain in that running state until something happens. For example, we get a phone call. Another activity, something like the dialer takes over. Well, then on pause will trigger that our activity continue to live in the background, unless the device starts to low on resources or something else needs our resources with a higher priority, then it will kill us. Otherwise, we'll live in a pause state until the user comes back. Then we go back through on resume, and we will run the activity again. Or in the case of like a device rotation, we will be paused and then resumed. So pause gives us a chance to save all our information, re-render the device in a new layout, and then we can resume from there. After we've been paused, if the activity is no longer visible, we'll move to a stopped state. So one of the common questions I get is, well, what's the difference between paused and stop? I mean, what do I put in start? What do I put in resume? What do I put in pause? What do I put on stop? Okay. Start is a great place to put things that need to exist through when the or the activity is in place, and should remain in memory even if the activity has become paused for some reason, or some piece of setup that needs to happen there. On resume is a great place for us to say, okay, maybe check and see if information's coming from a paused state. Then we will go to a resumed state after that. So when we are paused, the activity may be visible and it may not be visible. And then we are stopped when we are no longer visible. And then we will go through a restart, especially if it's been a little while, before we come back visible again if we've been cleaned up, depending on how it goes. So we go to stop, we go to restart, to start, resume, back through that, okay? And then if the user is being destroyed, if the activity is being destroyed by the system, or the user presses an explicit back button all the way through, then we'll go through a destroyed state, and then we are shut down from there. Now, there are a ton of moving different pieces, and I find that students often have a hard time seeing, well, what's happening when? Okay. Well, there's a great way for us to show that, but also have a discussion about some of the key things that are happening here. So I've got a project that I've started up. And this is just a blank project. It's the same thing basically like you did last week for your homework assignment with Hello World. The only difference is I've come in and I've added a little bit more code to help us see this process. Now, each of those life cycle events, you'll notice start, resume, pause, stop, restart, destroy. I tried to order them in a similar order that you saw them in the diagram to maybe help you see some of those connections. And then in each of these methods, or in the callbacks, I've just simply put a log. Now, a log.d is a method that we can call when we want to write something to Android's logcat. So its internal log file. Logcat is a view that will allow us to see all of that log information while the device is running. Now, inside of the log, there are several different ways we can log information. And it depends on the type of information you're wanting to output for what you're going to do. For example, log.d stands for log debug. So when I want to put something into the logcat for part of the debugging process, while you're during development, a log.d is the best way to do that because when you compile a release build, the log.d statements will be ignored by the compiler. Makes it easy to keep debug stuff in your code and not be dumping a ton of extraneous information into the log. There are also several other log types that we can use in addition to the D. They're all going to be single letters, so we can do also a log.e, which will stand for error. We can do log.w, okay, or we can do log.i. And then when you're in the logcat, you can filter between all of those, between warn for W, I for info, D for debug. Verbose is a view, not a logging specifically. It means show me everything. Assertions come into place when we are doing, when you get into UI testing or unit testing and stuff like that. So the stuff you really care about are debug, info, warning, and error. Now, info, warning, and error will write to the device, even in a production environment, unlike debug. And sometimes that's useful if you want, the user, for example, may need to send you a log so that you can figure out what's breaking when something's stopping. But we need to be really careful with the amount of information and the frequency here, because every time we put one of these statements, we're going to force Android to write something to a file on disk. And those I/O cycles are going to slow our application down. Now, it doesn't mean you can't use it. It just means be judicious. Be smart in your approach to using the log statements, whether it's a debug, an information, a warn, or an error. And then also, you should use the appropriate level so that Android can use some internal intelligence itself to know what's going on with what you're trying to put out. But do be careful about the type of information you put, especially if it's not in a debug statement. There's been quite a few famous cases, and you may have read some of these on the internet of the past, about app writers logging information, other apps being able to get a hold of that information, and now all of a sudden they have very sensitive data. There was a famous one where the cell phone providers, because they were not used to the change when smartphones were first taking off, they'd been used to dumb phones where nobody could download apps and they were in complete control of everything, had a log where every time you pressed a letter in the keyboard, it put it out into the log as an info statement. essentially resulting, if somebody could get a hold of the log file, they had everything you typed, including your passwords, your bank account numbers, credit card numbers, whatever it was you happen to type. They had access to all of those types of information. Okay, so remember, the log is an unsecured location. Anything you put out there will be visible to any other application or the user, and sometimes even malicious cases in the case of an infected device. So be careful with the information you put out there. Don't be afraid to use the log. You know, it's great, especially for during development. I mean, how many of us have always done, the print-style debugging? Well, the log is the easiest way to accomplish that in Android, where sometimes you just need to dump something out and see if something is happening, where or how you think it is. So in this case, I put our log.d statements in here so we can see all of these different lifecycle events taking place. So as you can see, I have just the log.d for my create, my start, my resume, my pause, my stop, my restart, and my destroy. Now, one other little note to prevent confusion from you in the future. Sometimes students get a little confused by this part right here where it says tag. Notice I can't even select that piece there. I don't type that piece. That is created by the IDE automatically to give me a hint as to what this variable or this argument I'm passing to the D method is. So the first argument I'm going to pass is a tag. Now, tags allow us to easily search out debug messages when there are a ton of them, or to filter our debug messages. Oftentimes, they're something, especially when you have an application with a lot of pieces in it, you might have a tag for each activity, or a tag for each fragment, or maybe a separate tag if you're inside of a class. The organization is up to you what makes sense and helps you find the information you need. But that's what the tag is for. And then obviously the MSG, or the message, is the message that's going to be logged out on the log. So if we go ahead and run this application, I've got an emulator here. Let's get this guy started up here. Now you'll notice, at first when this launches up, my log is full of tons of information because the log is constantly dropping information, from various devices or applications, everything the operating system is doing. If this was a real device rather than just a virtual machine, this list would be moving so fast you almost couldn't read what's happening because so many things are being written to the log at once. This is a great place where you can again choose the different levels. For example, I could say debug. Show me only debug messages. Well, there's a lot of debug messages that have been dropped, which makes it kind of hard to find the messages that I put into my code. And this is another place where we can use our tags. So I could type in as a one-time search cycles, my tag that I type in, life cycles, and now I can see, okay, well, on create was triggered, then on start, then on resume. Just like we saw in our diagram, we went from create to start to resume. And now we're living in this activity running state. Notice I didn't get a method or anything that happened to that. The resume was the last thing that was fired for me. And now my activity is running, and it should be responding to anything that the user does. For example, if there were buttons they would click on or other things like that, then appropriate event handlers for those UI components would come into play. But my lifecycle events are on hold for a few minutes. And we can also see now as, for example, here's my device right here. Let's imagine my user is using my application and I get a phone call. That's a great place. So you guys can easily test these types of things if you hit these three little buttons right here at the bottom, the advanced controls or the extended controls for your emulator. And then we can type in, or click a little button here for call device. So my device begins to ring. My user can choose to answer or decline. Notice if I hit decline, nothing happened. Now, why did I not get another lifecycle event when my user declined anything? Okay. If you said, well, because the activity didn't change its state, that's correct, because it was just a notification that had come down. It'd be the same thing as if my user clicked it, pulled down their notification bar from here. Notice no lifecycle events again. But let's say the user gets another phone call, and this time they answer the call. Notice immediately we get a pause for an opportunity for us to save all of our information, but because another activity is now over the top of our activity, we were stopped completely, which means the operating system freed up all of those elements, all of the memory that it was using to hold our UI and everything else that was on the screen, so it could be used by some other process. When I press hang up now, so that I will be returned back to my activity, or if I were to hit back and leave my call going even, but something that triggers the resumption of my application. It comes back to the foreground. And I hang up, I go back through, now I get a restart, a start, and a resume. Okay, a restart is an indicator that we will see in our activities, right? We see right here, whenever the operating system is trying to hint to us that we should pick our state back up. Okay, when we're launched from the first time, we'll go through create, start, and resume. On restart will never happen. But if the user was somewhere else and it has come back to us, maybe they flipped into another application for a second. You know, how many times have you guys, if you're using an Android device, hit our recently used applications, you know, you flip back and forth between a few and you go back. Every time you're switching in and out of those, you want the application to come back to the state that it was in before you left. And on restart is a way that we can start to handle those components coming back into play. Now, we will use a lot of these life cycles as we go on, and we'll talk more about, you know, as you start to learn what pieces need to be involved in application development, we'll start slotting them in different places and help you see what components belong where and what best practices are. But you've got to start to be aware of now first and understand what activity is, or what each life cycle step in the activity is, and how they interact. How do they play together? Which ones can you rely on for different areas, and start thinking through how you would set things up along those lines. Okay. Now, just like our activities have a life cycle, fragments will also have a life cycle. Now, a fragment, probably most of you have never even heard of that term. We will talk about them much more in depth next week. But for now, just as a brief introduction to fragments, a fragment is a reusable piece of user interface. So that way we can, you know, for example, if we look at this little diagram here, let's open this guy bigger. A fragment allows me to put all of the logic here for this piece and all of the logic here for this piece. Those are two different fragments. On a tablet, I can show them side by side, or on a handset, I show them one at a time. But that way I can support multiple devices, I can support multiple layouts in a lot of circumstances without having to recode things. An easy way to think about what fragments are is to think about object-oriented programming. Okay, now if you think about the object-oriented paradigm for just a moment, what's the purpose of a class? Why do you guys define classes? Why do you put things in classes? I mean, why do we organize that way? Is that enough of an awkward pause for you to think through the answer to that? If not, go ahead and pause the video for a second. But hopefully you said, well, it's object orientation is all about reusability. It makes it so we write things once, but we can use it in lots of different places. We can organize ourselves. Fragments are the same way. The difference is now, rather than just encapsulating logic or data like a class does, right? A class encapsulates behaviors through methods and data through attributes, through our variables of a class. Those two things are encompassed inside of a class. A fragment takes it one step further. Now we don't only have data and methods, but we also bring into play user interface. So you can think of fragments along those lines as it's a encapsulated, reusable piece of the user interface. Now the fragments will have a little bit different of a life cycle, and again, we just want to introduce you to these concepts this week, and we'll continue to build on them throughout the semester. But a life cycle of a fragment, you'll see, is similar, but a little bit different to an activity. Now, life cycles didn't really come on the scene until Android Honeycomb. When fragments came onto the scene was in Honeycomb. With the first Android tablets, and the need to really have a more flexible approach to our user interfaces. Activities have too much overhead to them, which is why one of the reasons why a best practice is in applications will be single activity things, and then we will have as many fragments, and these fragments can add and disappear and remove and change and all those things at will within the activity. Now, when a life cycle of a fragment, we start at the top, obviously here in the blue, when a fragment is added. And then the very first thing that happens, okay, because fragments are actually constructed before anything else happens. That's so we construct our fragment up here when that's really what's going to start to trigger off some of these things. Okay, as we construct it, and then we'll use our fragment transaction manager. Okay, and then we will attach that fragment. This onAttach callback will give us a reference to the thing that holds it. Who's our parent? What's the activity, or in some strange cases, another fragment that is that's responsible for this fragment? Because we're going to be tethered to its lifecycle. For example, if the activity that holds me goes to a stop state, I'm first going to have to go through the necessary places to end up at a stop. If my activity is destroyed, well, I'm going to have to end up destroyed, because I can't be attached to or referenced by something that doesn't exist anymore. So we will first be attached to whomever owns us, then we will be created. Once we have been created, we'll have the opportunity now to create view. Notice the separation, though, in fragments here between onCreate and onCreateView. Fragments will separate these two different pieces apart. Then we have our activity created, our start, our resume. Our fragment is now active. Now, depending on what happens, if the user navigates backwards or our fragment is removed or replaced, we go through pause, a stop, and then move straightly to a destroy and a detach. Okay? Because when we go backwards, or we remove/replace this fragment, it will no longer exist. So we need to clean up behind ourselves by destroying the view, destroying and detaching from whoever our parent was. If we exist on the back stack, right, we pause, we stop, we destroy view. If, for example, some reason though the user uses the backstack to return to us, then we start back up again at create view, activity created, start, resume, and running again. Okay, so this pathway here only happens when the user has navigated away from us and then uses the backstack to come back. We come here because, again, now we need this, much like that restart side. We need to reset whatever was inside this fragment, whatever its layouts were, whatever its data was, etc. All need to be reset so the user is back to what they were seeing before, to create a logical connection between where they were to now coming back to where they were when they went somewhere new in between. So we will go through this cycle here in those cases. And if we're not being restored from some previous instance, if we're not being reincarnated, I guess, in some ways, we are going to just go straight through to destruction from there. Okay? These life cycle events are going to, again, be the thing that will drive our application. We have to start to learn to think in this process of events. Okay? Now, I am not going to walk you through an example of each of these life cycle in a fragment. Instead, I'm going to suggest that after you've finished watching the videos for this week and you know how to make a fragment, take a few minutes. It literally will take you maybe 10 minutes at the most. Make a quick little demo for yourself and practice creating all of the different events or lifecycle callbacks in your fragment and run your application. Explore, see what happens, try doing different things. If a phone call comes in, a text message comes in, you push the home button to switch somewhere else and then you go back through the recent stack to get to your application, or if you relaunch it again from the app tray, or you back all the way out with the arrow versus just pushing the home button. And watch how your application will respond differently to each of those different circumstances and the different life cycle events that are called, and they'll especially pay attention to the order those life cycle events are called in. Okay? All right. We'll see you in the next video.